Now that we have a better understanding of landslides and the physics and geology behind them, we've made a simple yet effective model that will demonstrate these things. This cardboard piece will act as our slope, with one side representing an unaltered surface and the other representing an eroded surface. We'll be using these two blocks to represent materials that are unaltered and materials affected by water. First, we have the unaltered material on the unaltered slope. As observed, the material doesn't move. From the side, it can be observed that the gravitational force is made up of normal force and shear force, while the shear strength is dependent on friction. When the shear strength is greater than the shear force, the material will not move. When it comes to the eroded surface, since all factors besides friction are constant, shear force would be constant, while the shear strength is lessened. Now that shear strength is less than shear force, the material will slide down the surface. With the material affected by water, the situation is different. Again, the shear strength is weaker than the shear force due to the addition of water and the loss of friction. This will cause the material to slide down, regardless of the rough surface. When the water-affected material is on an eroded surface, the slipperiness of the material and the smoothness of the slope will make the shear strength even lesser compared to the shear force, making it even easier for the material to slide down. When the slope is steep, surprisingly, the material slides down. Taking a deeper look again, as the gravitational force is larger, the shear force becomes drastically larger as well, while there is little to no shear strength holding it up. With a similar concept to the shallower slope, on the eroded surface, the shear strength decreases yet again, making it easier to slide down. With the water rock, there's again not enough friction, causing the material to slide down. The same is true for the eroded surface as well. Okay, bye.